Our next speaker is Waiman Meinhold. Meinhold. Lead mechanical engineer at Shinkei, and he'll be talking about smart catch, the Ike Jime techniques meets modern technology. Thank you very much.
Thank you.
You'll need that too.
Yeah, thanks for having me here. I'll be talking a little bit about our robot that automates Ike Jime for sort of a different take on using AI in fisheries. So just for a little brief overview of this presentation, I'll go through some background, what Ike Jime is for anyone who's not familiar, how it affects quality and maybe welfare. I'll talk about our smart Ike Jime machine called Poseidon. I'll give like a little bit of the workflow of the machine. Unfortunately, there won't be any videos of the internals. I'll talk about some of our initial results and then some future directions and some time for questions. Yeah, so what is Ike Jime? It's an artisanal slaughter technique originally developed in Japan about 400 years ago. It involves basically killing the fish via destruction of the brain. It's accomplished with a brain spike, so like a physical tool, and then bleeding via cuts to the gills and maybe the tail, depending on the species. It improves quality both through reducing physical struggle of the fish, so reducing bruising and other damage to the meat, but also via the bloodletting. There's been some mixed results from a welfare perspective. Some EEG studies have shown sort of killing from the brain spike that's permanent. Some have shown mixed results. But I think a big part of that is that it's very difficult to achieve results doing this technique manually. At least it's very difficult to achieve them reliably. So you see a pretty broad spectrum of responses of fish to the technique because all of this is done by hand, typically. So that's where our smart slaughter machine, Poseidon, comes in. So this is what the machine looks like. This is installed on the deck of a fishing boat. It's currently in operation. Essentially, it automates the Ike Jime process. We use a computer vision model that's generated via AI to target the brain and gills on an individual basis, so on a per fish basis. So far, we've done a pilot in salmon. We've done a bunch of sablefish, rockfish, black sea bass, and a snapper species in the US. And we have roughly 3 millimeter accuracy at the end effectors, so the physical parts that actually accomplish the braining and bleeding. The machine is about 315 kilograms, and it's a little over a meter long and about 2/3 of a meter wide. Yeah, this is what it looks like. So a rough workflow of the machine, a fisherman loads the fish into machine. This is done manually. Currently, we work in pot and longline fisheries, so the operators are handling each fish individually anyways. So they start the machine by pushing that the screen button here. And then the camera detects the fish and the machine constrains the fish, so it holds it in place. Then our machine learning model inferences where the brain and gill cut locations should be on that specific fish. The end effectors first brain the fish, destroying the brain, killing it, and then bleed the fish by cutting the gills. Then the fish is ejected from the machine into like a bleeding slurry, and the machine resets for the next fish. This is all accomplished in roughly 6.8 seconds. Depends a little bit on the time it takes the operator to load the fish and also the size of the fish. So just some brief results and like the fish that we've run through the machine so far. So all of the results I'll talk about are in sablefish. It's for a couple of reasons. Primarily that this fishery is local to our office in Los Angeles, California, so it's very easy for us to do experiments with the fish. They're roughly 1 to 6 kilograms, and time to rigor is the primary metric that we use that is related to pre-slaughter stress. Obviously, it doesn't tell the whole story, but it's just something that we can measure relatively easily in our office. The fish are trucked to our office, so I wouldn't take the number of hours post-mortem as representative of what we expect in like actual harvest because the transport is stressful, so these times are probably a little bit faster, whereas we would expect them to be longer when the fish are run through the machine directly after harvest. This is just an example from 2 individual fish. This is a sort of standard harvest where the fish are asphyxiated, and fish reaches full rigor in about 7 hours. And then this one is from the same trip, but one that went through our machine. And you can see it's roughly, what is that, 9 times longer. We also have compared this, so our robot Ike Jime process to both Shinkei Jime, where the spinal cord is destroyed via wire, and then hand Ike Jime, so the manual process and asphyxiation. This is roughly 20 fish per group, and we've seen that, time to rigor is quite a bit longer with both our machine and Shinkei Jime, which is what you would expect given that the spinal cord is destroyed and you don't have any peripheral reflexes preserved. Another thing that we're able to do because this robot is so precise is we can actually look at how the location in the brain, so like specifically which part of the brain is destroyed, affects time to rigor. And we do see a significant difference between when that location is in the front of the brain versus the back. Actually a very significant difference. And when we target the back of the brain, we see time to rigor that's nearly the same as Shinkei Jime, so where the spinal cord is destroyed. Whereas in the front of the brain, you're closer to a manual Ike Jime, but still much better than asphyxiated fish. And I think there's a lot more work to do here now that we have this tool to run these experiments. I think investigating sort of why this difference occurs and how we can improve slaughter by collecting more data is a really important thing to do. There we go. Another thing that we have been working on, this is sort of a separate effort, but quite related, is trying to estimate the quality of individual fish. So moving from like a lot-based quality grading that is currently standard in the industry to grading each individual fish so that we can predict peak quality and shelf life. And the way we're currently approaching this is collecting an array of different sensor measurements, including images, and then trying to model the relationship using a machine learning model to organoleptic score or other objective measures of quality. This is a very early stage effort on our part, but just something we're working on for the future. And then to get into the sort of valorization part of this, which Michelle mentioned earlier, I think that it's really important to show how we can like leverage the value that's gained from the fish going through this machine to actually create like a sustainable business. So that's Shinkei's fish business, which we call Ceremony, and the fish we sell is Ceremony grade. This is basically just like a quality standard and really like a brand that we sell our fish under. So our fisherman partners actually lease our robots for $0. So this is just like we continue to own the machines and we maintain them and are responsible for any repairs that are needed, but the fishermen have them and operate them on their boats. And so our fish business actually purchases the fish that go through our machines. So the lease agreement actually gives us right of first refusal on any fish that go through the machines. And we are able to do this with high confidence because when the fish go through the robots, we know that they have an improvement in quality and that we reliably see that improvement. So this allows us to pass that improved quality on to our customers, and for that we charge our customers a premium. And so far we've mostly done this in like the high-end food service market, so nice restaurants and distributors that sell to nice restaurants, but we recently launched in retail in the US, and our goal is to achieve something approaching price parity while continuing to like see the benefits from improved quality and reliability. Just a nice case study on like how improved quality can be passed all the way through the value chain. With that, my email is here. Feel free to contact me with any questions, and I think we'll be getting into those now as well.
So thank you, Waiman. That was really interesting.